Well, thank you for joining me on this exercise 2A. I'm going to be looking at question 12. For the function y equals x to the power of 4 minus 4x cubed plus 1 without a calculator, the coordinates of the y-intercept. So the y-intercept is when x equals 0. So let's substitute. It's always also the constant on the end, so that's what it will be. But if you substitute x is 0, you should get the y-intercept is 1. So at 0, 1, it's crossing the y-axis. B, the behavior of the function as x approaches negative infinity and as x approaches positive infinity. Well, negative infinity, y is negative infinity to the power of 4 minus dot dot dot. It's the leading term which makes the difference. These cubics and the units won't make any difference. So a negative to the power of 4 will be approaching a positive infinity. And when y is positive infinity to the power of 4 minus whatever, that's a power of 4, also will be positive. So really, the graph as x approaches negative infinity will be approaching positive infinity, and as it approaches positive infinity, it also approaches positive infinity. Part C. The location and nature of turning points. Turning points happens when dy dx equals 0. Let's get the derivative. So dy dx will be, that's 4 times 1, 4 ones are 4, and drop that 4 down to a 3. Now 4 threes are 12, and drop that 3 down to a 2, and 1x power of 0 is 0. We'll let that equal to 0, and we'll factorize this. So we've got 4x squared x minus 3. Therefore, x will be 0, or x minus 3 will equal 0. Therefore, x will equal 3. So it's turning points, 2 turning points, one when x is 0 and one when x is 3. So when x is 0, y will be 1, as we worked out before. So there's a turning point here. And when x is 3, y will equal 3 to the power of 4. It's just substituting into the equation for the function, and you get 81 minus 4 times 27, 108, plus 1. And so 82, take away 8 is 26. Is that right? Okay. So at the point 326, there's a turning point. It says here the nature of the turning points. Okay, so the nature of the turning points, we substitute into the second derivative. So the nature of 0, 1, substitute x is 0 into the second derivative. And the second derivative, the derivative of the first derivative will be, there's the first derivative. So that's 4 times 3 is 12, and that 3 drops down to a 2. And 12 times 2 is 24, that x drops down to a 1. So when x is 0, therefore d2y dx squared is also 0. Now it could be a point of horizontal inflection, and we'll explore that. Now let's look at the nature of the other turning point. Let's get this, the nature of the turning point 326. And so we substitute x is 3 into the second derivative, and we get d2y dx squared will equal 12 times 3 squared minus 24 times 3. So 12 nines, 108, minus 72. Okay, so we're dealing with a positive number, and since it's positive, it's concave up, therefore it's a minimum at 326. And finally, the coordinates of any turning points where the second derivative is 0. This is a point of inflections, and so we said that the second derivative is 12x squared minus 24x. Let's factorize that and solve it. 12x, leaving x minus 2. Therefore, when x is 0, or when x is 2, we have a point of inflection. So let's say we got 0, 1, and 2. We substitute 2 into our function, and y is 2 to the power of 4 minus 4 times 2 cubed plus 1. So 16 minus 4 8s are 32 plus 1. So it's negative 15. There is a point of inflection. Finally, we want to sketch a graph. All right, so let's put all these points on a graph. Let's get a graph here. And a graph down here, put an x-axis. How do I get rid of that? Okay. So what have we got? Y values. So the x values and the y values, we've got to negative 15. We've got 0, 1, and 2. We've got the points 326. So we've got the points 326, 0, 1, and that's it. So we need to have up to 26 down to negative 15. So let's go 10, 20, 30 on the y-axis, negative 10, negative 20, and let's go 1, 2, 3, 4, 5, negative 1, negative 2, negative 3. And let's play our points. So first of all, we got 0, 1, so we'll put that here. That's on the y-axis. We've got the point 2, negative 15. 2, negative 15 is here. So 2, negative 15. We've got, that's our point of inflections. We've got a turning point at 0, 1, and 326. So 326, and we have a minimum at 326 and a point of inflection. How's that possible? Did I make an error somewhere? 2, negative 15. 3, oh, it's negative 26. Okay, yeah, there's my error. 3, negative 26. Let's fix that up. So we don't want that at positive 26. We want 3, negative 26. So that's, luckily it will fit. Okay. And it's going to be going up and up as we establish. So it's going to be a point of inflection here. So this is a point of horizontal inflection. This is a minimum. This is a point of oblique inflection. So we come down and we're going to be turning there, leveling out. Then it continues, and We didn't find the x-intercepts, but it's going to cross here, and then this is the middle of the S-bend, and then it's going to suddenly turn there, and somewhere it's going to cross the x-axis, and there we have our graph. So that's 2, negative 15, 3, negative 26, 0, 1. That's x, that's y. All right, I hope this has helped. Until next time, stay happy.